Well, g'day. I thought I'd make another quick video, and just before I went to start, so I stepped outside and had a look at the sky, and I'll just do a quick and look at the big mart of chemtrails that have been spreading across the sky on what would otherwise be a beautiful, clear, sunny day. Now, it's really bright out here, and this is a lot of my storage device, and I have to get back inside and get on the charge, and then I'm going to go ahead with my very short presentation that I thought I'd make, and then I realised, oh crap, I haven't prepared this very well at all, but I can pause it. Right, yeah, thanks for your patience. I haven't obviously prepared this too well, because what I wanted to do was get that clock in the frame. I wonder if that'll stay. It's trying hard. And the AE map, it's got a slowly sinking feature, but that's all right. I've got a tripod. Makes me try harder. There we go. We've got the clock. So this is a little chat about time. And this is one I've been actually wanting to do for some time. As you can see, I put a little copyright in there. So that means if you do want to use my stuff, just contact me, and that's fine. I'll probably give you permission if you're not a glober. It is actually Sunday, which that's why I had to pause the video, because this one is like freaking empty, man. No, well, yeah, now it is. You can never judge a bottle by its contents. Whoa, man. It's very good content. Rightio. I wanted to talk about time, and the best time to do that is now. So here I am now. Unfortunately, I was watching a really cool Jeranism live, and yeah, don't get me wrong. Or do get me wrong, I don't care, fuck it. I reckon Jeranism and Whitset and all the Globebuster community are the bomb. I love them a bit, so I think most of their stuff I will agree with most of the time. And you get these channels like, I don't know why I'm still subscribed, but that's that Quantum Chicken Choker, I think it's called. No, it's Eraser, that's it. I still subscribe to him, and as I say, I've no idea why. Let's straighten that up while I'm yakking away here. All they do is get on and bitch and bitch and bitch about other people, and it's not productive. But meanwhile, of course, Jaron is also, when he did his live, the first half an hour to an hour was also a bit of bitch and bitch and bitch about that life. I think the Fed, the Flat Earth debate, Nathan, it's not even Nathan Thompson, is it? It's Nathan, anyway, that Pommy guy. The most annoying, irritating, aggressive, rude, obnoxious. I'm gonna get this camera level one of these days. I swear a lot. Okay, how are we looking? Not that great. What we want to do is look at the azimuthal equidistant map. Ideally, I'd be doing this with graphics like all the professionals do, but this is the Iron Horse channel, and this is as professional as it gets. I'm using a light, god damn it. And I also prepared one earlier. So cheers and merry today. It's a great day to be in existence, because the alternative sucks. I'm still not happy with the angles. I want to sort of make that clock. I really need to put everything up higher. I wonder if I can, without causing too much disturbance in the space-time continuum. That looks a bit better. Lock, stock, and 2 smoking barrels. Rightio. That'll do. So the clock. This is a 24-hour clock. It goes from 0, which is the equivalent of 24, all the way back around to 0 again. So it's basically telling you time is non-existent, and I think that's the most important thing to think. Time does not exist. However, on the other hand, we have a time and longitude calculator, and we've got a new cat. It's still a kitten, and it likes to attack my ankles all the time. That's okay. I'll find something to throw at it eventually. And it does the same sort of thing. It's got the V1 up here, and it's got the X11 there, and it's got another V1 there, and another X11 there. So they're basically saying 12, 12, 6, 6. So in a sense, you've got 24, 12, 18, 6. Or so 0 to 6, 12, 18, 24. This goes 0 to 6 to 12, 24. Now it doesn't matter. Because it's a dial, it doesn't matter. All the numbers are just placeholders. You know, like here, because that's the hour hand, sorry. The little one's the hour hand, that's the minute hand. The little one here is now pointing at 16 towards 16:15, because that's the 15 minute for the minute. If you know how to tell time, it makes sense. So if I got my big fat head in the way, 15 minutes past 4 o'clock, and that is the actual current time here in Eastern Standard Time of Australia. And so if we looked at this on this map right here, we would locate that. So the hour hand is, there's the 4, so it would be pointing there, 4:15. And so midday right now is approximately at Perth. And I think that works because I might have to check that after, because it's not really important. The important thing is you got 24 slices of the pizza, and they match each slice of the clock. So this is where I'm going to get a little bit mathematical. I know, right? A flat earther, you don't know no math. So we know a circle is round. It's got 360 degrees. So there is 180. And 360 is also a 0 point. So it's also a 24-hour clock. That's your 12 point, that's your 6 point, that's your 9 point, or alternatively, it would also be your 18 point, if that's your 12. On a 12-hour clock, it's a 3, 6, 9, and then the goose drink wine. Monkey chewed tobacco on the street. So really, if you just want to look at it in a logical sense, if we've got 24 hours in a day and there's 360 degrees in a circle, then it's a simple matter of long division. 24 goes into 36 once, and then you subtract that is 12, then you drop down to 2 and it's like 5, and 5 4s are 20, 5 2s are 10, add on the 2, and 3, so you get 0. So it's 15 degrees. Come on. Don't turn into a 6, you dirty little. 16 degrees an hour. So that is how fast the hour hand is moving, is 15 degrees per hour. Very logical sort of stuff. If you want to know the linear speed, well, you have to understand the circumference. So if we looked at the equatorial circle there. The equatorial circle is about 24,901 approximately miles. It's close enough we could round that off to 25,000 miles. So what you would do then is, we've got worked out it's 15 degrees per hour. If we've got 25,000 and we've got 24 hours in a day, then we could just see it like add in that once. And so 1 times 24 is 24, and that leaves you 1. So you've got to, and 24 doesn't go into 10, so you've got to drag another 10 down. 24 and 100, ooh, is about 4. 4 4s are 16, 4 2s are 8, 1 is 9. So that leaves us a remainder of 4. So then we have to drag down another naught. 24 into 40 goes once. So if we do that, then that's 124. And then you got 6 and 2. No, you have to borrow a 10 from there to get 6. So it's 1. It's 1. So then you have to borrow some decimal points from it. We can borrow as many decimal points as you want, because 0.000 is still naught. This is mathematics. So 24 and 16 don't go. So if we just borrow a naught from down here and we'll put it down here, 24 and 160, we can estimate probably about 6. So we'll turn that into a 6. 6 4s are 24, 6 2s are 12, plus 2 is 14. And then we got borrow 10 again, so you got a 10 minus 4 is 6. Pay back the 10, so it's 5 minus 4 is 1. And we've got 16 again, so we have to borrow another naught. So then we've got another 160, so we do another 6 times 24 is 144. And so we can see that's going to go on ad infinitum. So we know that it's 666 repeater. I don't know what the fucking thing is. What we just do is just call it 7. Because it's just going to keep on going forever. So now that has given us a linear speed of 1,000. You have to put the 0 in, sorry, I forgot to put the place marker in. 1,041 miles per hour for the clock hand moving 360 degrees per 24 hours, or 15 degrees per hour, is going 1,041.666, etc. miles per hour. Rightio. And if you don't trust any of the math, trust me, I do, because I know it. I'm actually a natural born mathematician, but I try not to brag, and I actually took some notes. So if you wanted to go the other way around, I think I already did it, didn't I? If we say that there's 15 degrees per hour, but there's 360 degrees in a circle, you can do it that way as well. 15 into 36 goes twice. So we do 2 15s is 30. And then we're left with 6. We bring down the naught. 15 goes into 6, 4. 24 hours in a day. It all goes every way. 15 degrees per hour. Watch out, you little cat. Oh, how dare you. I love my cat. Hey, Tutu. Come here. Say hello. Hey, don't bite me. It's biting me. Look, that's you. Oh, she's the cutest little tootie. Bite me one more time. Go on, bite me one more time. I will. Fucking hell. I didn't mean literally bite me. Go and run along now. Good cat. Lost my train of thought. Rightio. So we can look at it any way you want. 15 times 24 equals 360. I think it's pretty straightforward. There's 360 degrees in a circle. There's 15 degrees in an hour. And the mechanical clock does not lie. This is really all I want to talk about, so it's not going to be a long video. I tried doing a live and it didn't work, so I'm just doing it this way. So hang on 1 second. Rightio. So we've established, I think, a basic model for the flat Earth. So when people say, for example, on the globular model, that the globe is rotating as fast as the hour hand, and we've barely noticed that movement. It's been going 10 minutes almost. In all that time, it's barely moved. It's like watching paint dry. And so that they will say then, therefore, that the Earth is rotating very slowly. Now, this video is done to tell you that you're wrong and you're wronger on both assumptions. The 0.00694 RPMs, which is how fast the hour hand is moving, I could show you the maths for that as well, but I think you can work out there's 60 minutes in an hour. So all you have to do is divide it by 60 again, and that gives you 0.00694 RPMs. It is a correct measurement for how fast the hour hand is moving. However, if you did extrapolate that back out into a globe, and that's how fast the globe is rotating around the equator, then that is where you get 1041.666 miles per hour actual speed, the ground beneath your feet. And so therefore, if you really seriously think the ground beneath your feet, even though you might be hundreds, maybe even thousands of miles away from the equator, and it adjusts accordingly. Here we have a boy. It's just a little boy. Well, that's what we call them over here. Some people call them buoy. It's just a floating buoy. I think China goes on top, sorry. That's the equatorial speed. So obviously when you're rotated at once per 24 hours, then the fastest speed is going to be there, but it's still going to be mighty, mighty fast, all the way down to the 60th degree and up to the 60th degree either side of that. If they divide into thirds, 30, 30, 30, well, there's your 3, 3, 3, magic spinning ball. It's still going bloody fast, okay? It's even if, well, it's still 15 degrees per hour. That's the whole thing. It's still 0.0694 RPM. So for all the globers who'd like to say it's only 0.00694 RPMs, you're correct. Congratulations. However, if I had a ball the size of that clock, hey, bloody kid, it'll technically be the same speed. However, linear speed rotationally is much faster. And so that's basically what I'm trying to get to with this video, is to say that time is speed. Hang on a sec. Let me think that through again. Time is distance. That's what I tried to say. Distance is time. Yeah. So that clock isn't time. Time may well be ticking. However, Einstein was onto something when he said it's bent space-time. In fact, I think I might need to go and bend some space-time into my lungs and get back to this, because this cat is dynamite. We will be back, and I will remember what I was talking about. Guaranteed. Rightio. So I just got a little bit of bending space-time into my system, and I feel maybe this can go on. So this is the biggest globe debunk of all time. So that's why we have to take our time doing it. In fact, why not? Why not? This is that occasion. It's not even the right app. We'll have to do. We have to go into wizard time for this one. So now that we understand, oh fuck me, I just got all the secrets of the universe in my head. Damn it, that hurt. Ow, I wasn't ready for that. Maybe tomorrow. Right now, we're just going to talk about. Oh, see what I did right now? Oh man, the time is always now, regardless. That's the thing. So my 4:30 was 4:20. So hey, what can I say? We might have lost a few minutes. My 4:20, so I live here, is there 2:20. And the people directly over here, coming to the easternmost point of South America, it is about there 4:30 in the morning. That's just the way of the world. And that's one of the ways I think we get tricked quite often, is because the time zones do mess with our heads a little bit, because a lot of people will ask, well, how is it coming into morning there and it's just coming into evening over here? And well, because if the sun follows the equatorial path, which we've established mathematically is 15 degrees per hour, and we've given it a linear speed of 1,041.6667 miles per hour, then everything works out just fine. The clock works, the map works, and we're all still here now. That's really what matters. However, if you want to be a heliocentric sun worshipper, head full of indoctrination, I jumped the fishbowl project, the bird tree decides each and every nation. It's understood that Hollywood sells spinning ball of magic. Where did that come from? Sounds like a song I might have to release again soon. So if everything's going around the sun, as this moon map has demonstrated for us, and it does so quite eloquently, because it's put everything into the proper zodiac signs. So unlike the 24-hour clock, basically every 2 hours of a yearly representation is the moon map, which is why there's only 12, so it's half of 24. I'm pretty sure half of 24 equals 12, but I have to check my calculator later. At least the cat's falling asleep under the chair, or purring at least. Don't you bite my foot when I kick you. She's biting my foot. Hey, I won't kick you. Deal. So, yeah, each one of them, there's 12 of them. So that's why we've got the 12-month calendar, even though we've got a 24-hour clock. And that all correlates. And I don't know if I can even draw this, but basically what we've got here with this clock, well, let's say that's him right there. Come on. It's a little bit pear-shaped, but it's oblate spheroid. So we've got the hour, minute hand down there, and that hour hand about there. Make them a bit longer so we can differentiate. The seconds we can do. This one here being the hour hand is the sun. Oh, I think we have to draw that in another colour. Because obviously everybody by now has the Flat Earth, Sun, Moon and Zodiac Clock app. That gives a heap of money to David Weiss. And he's actually going to send me 10% of the donations because of the little copyright thing I do. No, I'm kidding, Dave. I know you need your shekels. So if that's... Cat, can I have it back? So if that's the sun, and then therefore it's Australia, it's going to be done in rain. That's Australia. And then obviously we've got all the other continents. Doesn't matter about them because Australia is the whole world. It's the World Cup and shit. So it doesn't have a second Queensland either. It's just a lady bump. So if we have that, then we have to give us a blue moon. We actually just had a blue moon a couple of days ago. It was lovely. And now the moon, it lags behind the sun. Oh, what's the bet? It's probably about here anyway. Oh man. Let's just say it's back here now. And that's our moon. Don't sit on my foot. I might trip. I might trip. Damn ya. Anybody want a cat? I got a free one here. Say hello. Don't smash it. Don't rip its eyes out. Oh, you little sweetie. Yeah, little sweetie. The birds are getting your food. Quick, take the birds. Works for a dog. Oh. So, if that's the moon, it is literally exactly the same as the hour hand of a clock. So actually it wouldn't be there at all. Now that I'm thinking straight, cat put some sense in me. When we have a full moon, well, the sun will be there, but let's say it's moved over to there, then the moon will be over here. That's going to be our moon. It's over there. Now we're a few days past the full moon. We can just look to our clock calendar over here and see there's the full one there on the 31st of August. That's why it's a blue moon, because it's the second one of the same month. Hey! Don't scratch my ankle! I'll bloody get you. So on the 31st, that's where it was, and today is now Sunday the 3rd, and it's getting to be a third of the moon. So relative to the sun, I should say third full, it is moving synchronously with the sun the whole time, like a 24-hour hand. And that is why the amount of sunlight hitting it is facing that side. When it gets to here, well, actually that's not how it works. It's going to be 50-50. Quarter moon. When it gets to there, it's the other quarter moon lit on that side, and when it gets to here, the whole lit side is facing the sun, so we'll only see the dark side projected down here. You just have to get moon phases out of the way again, one more time. However, the sun itself can only move 360 degrees per rotation. The clock can only move 360 degrees per rotation. So when you see the idiots telling you that the sidereal motion of the Earth is only 23 hours and 56 minutes and a tiny little bit of change, but the sidereal day is 24 hours. What they're saying is that this is the Earth's path and they're putting the sun in the center. So we have to ignore all logic, just ignore that, it out and put the sun in the center and say now it's the Earth spinning on its axis and it's going from east to west on its axial tilt, somehow magically keeping the same tilt because it's somehow tidally locked to the sun. Didn't think about that one, did you? Just as the moon itself is tidally locked in a different sense because it only shows the same face to us, but in a sense, if the Earth is drifting around, but it's always at the 23.4 degree tilt, which is also the 66.6 degree, then it can only still rotate on its axis, once per 24 hours, because one rotation is 360 degrees, and it's the only way this side of the Earth, well, that side's in darkness, that side's in daylight. We put the Earth over here, that's the side in daylight, that's the side in darkness. We put the Earth over here, that's your side in darkness, that's the side in daylight. And same again over here, we'll make it bigger because it's summer. That's the side in darkness. I should have made it smaller. The other way, you exit. That's the sunlight side. It's always facing the sun. Well, the side facing away from the sun is your night. So how does it work? If there's only 360 degrees on the clock, there's only 360 degrees in a circle, well, what the globe will tell you is that the Earth, it spins around on its axis, but it goes 361 degrees, while the star field in the background goes 360. Now, that's the insanity of it. The clock can only measure 360 degrees. It can only measure 24 hours. So when they try and tell you it's 23 hours, 56 minutes, and some chump change, they're lying to you. There's 24 hours in a day. The Earth is always facing the sun. Now in this model, if the sun's going around above it and we're looking up at the sun is always going to be overhead 24 hours later, 360 degrees. We don't need to invent a sidereal day. It would just be complete and utter nonsense. However, because we do have this model of the Earth, which is a big blue circle, and we've got the sun at least showing that much of the Earth at a time and that much night, although most of the time it's that much and that much. The other side of things, how I showed the moon hour hand, well, there's also a star hour, and it's not so handy, it's more of an hour clock face. So if this clock face itself were a rotating disc, and here where the sun is now pointing at 4:45, if we just drew a line through there and said that part of the disc are the visible stars, then it is also rotating at the same speed as the hour hand of a clock, just a wee bit faster, almost a degree a day faster. So as that hour hand moves, and the sun hour hand moves 24 hours, and the moon hour hand moves 24 hours 50 minutes, the star hour hand, which is half a clock face, is moving 23 hours 56 minutes and change. So it's moving a slight wee bit faster. So again, when we look back to the astronomical clock, because it's a still image of it, what we have to imagine is that the whole zodiac is rotating 24 hours, but 4 minutes faster, 23 minutes and 56 plus change. So that is why when the sun itself has taken 365 and a quarter rotations around above the equator, the stars will be back at their original position. So every month they're just drifting. So the sun will appear to be in a different house of the zodiac, whereas it's actually the zodiac itself is what's changing. And this mostly only works for the northern hemisphere. The southern hemisphere is a whole new kettle of fish. And for that, I've bought a new children's toy. I just picked it up at Aldi's for about $8 or something. Haven't yet really opened it, but this one is called DIY Kaleidoscope with colourful shapes. So this is going to be a fun project for another day, because I don't have enough hours in this video to do. But as you can see, there's mirrors. That's a mirror, believe it or not. I wonder what happens if you put it too close to the camera. Will it do a time warp? We'll try that. That's 6 of these little puppies. Where's the camera? Here it is, it's doing the time warp. Which one is the camera on over there? No, it's not quite working. I'll try that another day. But what I have a feeling is that 6 or been ripped off. I've got 3. Oh, that's dodgy. Anyway, I'm going to read the instructions one of these days and put a child's toy together. The point of it, why I've got it, is I've been trying to get to the bottom of this for a long time. And again, I keep coming back to a pyramid, is that I think that the inner side of the equator, the northern part up to the equator, is kind of like what you see is what you get. But once you hit the equator, where is that little twinkly thing about the cat? There it is. You'd think the cat would get it because it's got a kiwi on it. I keep coming back to this because I really do think that there are so many clues in this. Is that this will show me where the camera is. It'll just move. It'll follow where the camera is. Star tetrahedron is a double-ended one of these. And you can just sort of see how each facet is projecting something other than itself. One over here, sure. Yes, I do. I managed to remember getting this years ago, and I knew that this was important to you. See, that's the star tetrahedron. This one's not reflective or colourful. It's fluorite, not fluoride. It's been around a long time, so it's a bit beaten up. But that's basically star tetrahedron shape. So if you can squash that right down and imagine that as the girl with kaleidoscope eyes. I know it goes into crazy things. Lucy in the sky with diamonds. Picture yourself on a boat. I'm going to try and draw a slight representation. So if that's the Earth down here, that's our blue sky atmosphere, that's our firmament up here. What if the firmament sort of had this massive star tetrahedron, and that's what's spinning around. So you've got, you know, when you look at a 4D pyramid, it's like that. So you've got all these facets. There's all these facets through it all the time. And each one of them, kind of like the, just the simple one. The simple one is reflecting another facet. It's just a four-sided pyramid, but it's reflecting and therefore projecting. So if the center of the kaleidoscope is what you see, what you get, so the star trails going around Polaris look perfectly normal, you could divide the four quadrants of the world outside of that, which is here. So you've got, that's the equator. So because then it reflects them, as we know, a reflection goes the opposite way. So the star trails appear to go that way. And then when they get here, they start going straight, and then they start going that way, over here. You know what I mean? And it does the same deal. They start to go the opposite way over there, or they start going above the equatorial regions. The equatorial region, so down on the Earth, which would be that big, that's your equator. That's where the star trails all look normal up to Polaris here, making perfect star trails. You get to here, they start to straighten and bend the other way until you've got an opposite and the stars obviously are different, but they will appear to be going the opposite way. But because this part of the world is divided into four sections, this part of the world is looking up at the exact same projection as each and every other quarter of the world is basically seeing. So there is seeing Southern Celestial Pole, down here, Southern Celestial Pole, over here, Southern Celestial Pole, over here, Southern Celestial Pole. That is what I think is how we've got the star trails mimicking what you would expect to see on a globe, going the opposite directions and showing the same stars that we would expect to see in the outer hemisphere. How many minutes have I got? I've got 2 minutes left. Showing the same as you would expect to see, because nothing is as it seems. And the firmament itself is still a fixed height. If that whole thing is what rotates, then that is what it can give us daytime, twilight, nighttime, twilight, daytime. And then as the sun gets, so if it comes down through here, it's projecting it further outwards as it gets lower. But as it goes higher, it projects it further inwards. Summer, as it's higher, lower, summer outside the equator. I'm hoping that makes some sort of sense. And I really didn't spend as much time as what I thought I would on the whole sundial 360-degree conundrum. But hey, talking about the star trails in the southern hemisphere is possibly even more important. And thanks for listening, and hopefully I'll see you around soon. Cheers.